All right, I hear the music and I see a thumbs up from the back, so it must be time to start. Good morning, everyone. How are you? I want to first congratulate you all for finding this room. I don't know how they decide to hide it, but I'm confident that you're all here at the right place because you found your way to the back of 𝗦𝗽𝗀𝗀𝗻 here. So thank you for joining myself and Ami and Anish here for the fine-tuning session this morning, where we're going to unpack and tell you about all the amazing fine-tuning features that we have. But more importantly, I'm going to have these two amazing people come up later and show you how you can actually customize a model from OpenAI with fine-tuning. So let's start with this quick video that's going to give you a brief overview.
Gemstones are shaped and polished to achieve their true brilliance, and we customize AI models for the same reason. Azure AI Foundry offers many ways to tailor models to your business: prompt engineering, retrieval, fine-tuning, and custom models. Without complex GPU setups or Python expertise, serverless fine-tuning makes advanced techniques more accessible. A simplified process lets you train models with smaller, task-specific datasets, so they know the nuances of your domain. You can initiate and compare fine-tuning jobs simultaneously to produce AI apps that are as relevant, efficient, and accurate as possible. Even the latest models are generalists, and to get the most out of them, we need to teach them about our business. Digital distinction is now about the quality of our AI experiences. Not raw materials alone, but the craftsmanship.
Awesome. I love that video. Thank you to my marketing friends for putting that together.
Gemstones are shaped.
So, what are we going to talk to you about this morning? First of all, we're going to talk about why. Why would you want to fine-tune? Where is that an applicable option that you want to apply? We're going to go into what's new with Azure OpenAI and fine-tuning of those models. We're going to actually show some demonstrations of how to fine-tune a model with vision as the primary use case. And then we've got our awesome partners here from Weights and Biases that are going to show you how you can evaluate and support that fine-tuning with the amazing integration that we have with their platform. So let me start with, what is fine-tuning? At its fundamental base or its core, fine-tuning is taking a general-purpose foundation model like GPT-4o and adding your data to that model to make it better at a specific task, thinking about adding domain knowledge or refining it to do something that you want it to do with higher accuracy, better speed, and lower cost. So why would you want to do that? Well, there's a bunch of reasons why you might want to fine-tune or customize a generative AI model. One of those reasons is scale. By fine-tuning a model, you actually reduce the amount of tokens that you need to send to the model, which means that it's less processing. So it allows you to scale your model more broadly across your environment. The second really important reason is to improve its grounding or reduce hallucinations. By fine-tuning a model, you actually make it more accurate. You reduce the number of inaccuracies or incorrect responses that you're getting out of that model because you're adding your data. That, on the other side, is improving reliability, to actually get more accurate results with every request that you're sending it. This is particularly important in highly critical domains like healthcare, where inaccuracies can actually cause negative impact to people's lives. Third is to improve efficiency. Like I said, with fine-tuning, you can actually reduce the number of tokens you need to pass, the number of instructions that you need to pass to a model to complete the same task. So as a result, you actually save cost on that model when you're doing the same task over and over again. And finally, to tailor your solution. You may be working in a specific domain or with a specific application where that model doesn't actually fulfill your specific task well. And so you can train that model to do what you want it to do with better responses every time. But let's click in and look at some actual applicable use cases. What would you want to do? Well, we know prompt engineering is very powerful, right? You can actually instruct these models with natural language prompts to behave in a certain way and fulfill the responses of your customer's requests with high accuracy. You can add in that prompt examples. We call that few-shot learning, right? Where you're actually within the prompt saying, hey, this is a good input and a good response, and you can continue to tailor that. Well, as you do, what tends to happen over time is your input prompt becomes quite lengthy. So one of the things that you can do is train your model with fine-tuning to actually build that prompt into the model itself. So that means on every request, you're not sending that massive payload anymore. You're reducing the prompt length. You can also use this to teach new skills. General models like GPT-4o are generally good, but that doesn't mean that they're good at everything. And there are times that you want to train a model to actually fulfill a specific task really, really well. And so you can actually train that task with sample inputs and responses to get it better at a very specific skill. And that's transferable to tools as well. You would have heard us talking about Azure AI Agent Service here. And with that service and assistance API, you can actually use an LLM to call a downstream function or tool. You can pass information in and out of these models. Well, that often requires the model to know that tool well, what specific format it needs, what specific information it can rely on. And so you can fine-tune the model to improve the accuracy of tool use. And then we talk about domain-specific models, models that are really good at your domain. Whether you're in healthcare, finance, legal, retail, manufacturing, any domain that you're in, you have specific knowledge which is tailored to your domain, and these models might not do that well in your context. So you can add your context to these models. Talking about domain-specific use cases, let's click one level deeper. What are some examples there? These are some of the most common scenarios that we're seeing customers today use fine-tuning. One is natural language to code. These models generally are very good at coding tasks, but not in all languages, right? Some languages like Python are better than others. And so you can actually get it better at NL to code tasks by training with samples of generating the type of code that you're after, the language that you need, the specific applications that you're supporting. That applies to human languages as well, with translation and dialect formatting. You may be building an application that you want to use all around the world in many different languages. And these models do an okay job, but they often miss the nuances, the cultural differences between the way that people speak languages all around the world that are beautiful. So you can build those nuances with fine-tuning into these. And that applies to domain-specific languages too. Like you might need to teach it about specific use cases in your technology domain, in your business domain, that it might not have the words or the language for too, and you can train that. We had a great example from the NBA on our main stage yesterday, where they were talking about words which, in the context of basketball, have a completely different meaning than in a context of the real world. Like, what does a shot mean? What does a dunk mean? What does a hold mean? What does a travel mean? Well, that's very specific to the game of basketball, and in that domain, it has specific context, so you can train the model in that way. And that gets to customer-specific knowledge infusion as well. You no doubt have proprietary information and documents in your enterprise that the general purpose models know nothing about. Well, you can add that to the model, and it remains secure. It is still your data. No one else shares that information that you're adding because you're creating your own custom weights on top of the model that is only applicable to you. So let's walk through this as a journey. I talked about how fine-tuning is different to prompt engineering, but the reality is these things work together. They're not isolated and stand alone. In fact, every use case that you're building will no doubt start with prompt engineering, where you will instruct the application on what you want it to do and how you want it to fulfill that task, what kind of language, what kind of stylistic approach you want it to use. The next thing that you'll want to do is you'll want to add your own data. And that is where retrieval augmented generation comes to play. This is where you can use a search service like Azure AI Search, taking the user's input, retrieving information with that input to answer the question. If you've used something like Bing Copilot, you see this happening all the time, where you ask a question, it goes and searches the internet, and then it summarizes all of the information on the internet to answer your specific question. That's retrieval augmented generation. But what if you want to go one step further? What if you want to actually add domain-specific knowledge or improve the quality of that response or the efficiency of that response? That's where fine-tuning comes in, where you can actually train the model with your data to more specifically answer your requests with higher efficiency and higher quality. You can even go one step further by pre-training your own model. There are open source foundation models today, and you can take those and actually build your own with your own data to make your own general purpose model for your scenario. And as you look at the spectrum from prompt engineering to pre-training, the intensity of compute that's required and the amount of cost that's required increases as you go to the right. But so does the quality and the ability to create results which are tailored to a specific domain. And so that's the journey that you want to go on as you're looking at your applications, starting with prompt engineering, through retrieval augmented generation, to fine-tuning, and then, and only then if you need to, potentially pre-training. So let's make it real. I want to show you a couple of examples of what this looks like. In this first fictitious example, you would have seen Seth and others doing this demonstration of building a retail application, where you can ask a question like, hey, I wish I was going to the Patagonia next month. I'm not, but that would be fantastic. Imagine I was going to the Patagonia next month, and I have a sleeping bag. I could be asking this application, hey, will my sleeping bag be OK for the Patagonia next month? Well, with prompt engineering, the application would know that it's a retail bot. It wants to respond to me in a courteous way, and it wants to take my intent and provide a response to that intent. With retrieval augmented generation, the application would look up my information as a customer. It would learn that I purchased a very specific type of sleeping bag. It would look up the weather in the Patagonia next month. And it would personalize all that information to provide a response. Going one step further, I could fine-tune the model. And I could take all that information, I could train it into the model, not the real-time information that changes every day, but things like the prompt instructions, things like context about the tools I want to call, like weather lookup and the customer database lookup. And I could train the model to be able to respond very specifically in a style and a format that I want. And with that response, it would create a response like this. Yes, your Elite Eco sleeping bag, Steve, is rated for 21.6 degrees Fahrenheit, far colder than I ever want to sleep outside, but we'll put that aside for a moment, which is below the average temperature of Patagonia. And it would be able to provide that response for us. So that's how these things work together. Let me give another example, which is Microsoft Cloud for healthcare. This is one of the first applications at Microsoft where we applied fine-tuning. This is in the very early days, but before I talk about how they did that, let me talk about what they do. They actually help clinicians all around the world in healthcare settings to provide better care for patients by using both voice input and speech recognition and AI to create the documentation that's needed in a healthcare setting and understand that documentation as well. So this team started with a number of approaches. They started with a general purpose model, like GPT-4. They started with a small custom model, an SLM. And they started with fine-tuning. And in their initial iteration with fine-tuning, they got OK results. They actually built a model with fine-tuning, and they tested it with customers, and customers were pretty neutral about the responses. They thought it was about the same as they were getting with the SLM. But they continued to refine that model. They continued to train that model for specific tasks that they wanted to perform. And today, they're using that model for many tasks within that setting because customers say that it's far better. And in fact, their application uses a combination of all three. It uses fine-tuned general purpose models, it uses small language models, and it uses a non-fine-tuned general purpose models for a catch-all use case. And the point is, it's not a one-size-fits-all magic bullet here. It's about thinking about the specific scenario that you want to solve and training for that scenario and tailoring it and continuing to train it. And by doing that, you can, over time, these models can get better and better. So what's new? What are we going to dive into? That's what fine-tuning is. Now let me talk about Azure OpenAI. And I'm super excited to be announcing this week that we have some amazing new capabilities that are in preview and are going to be in preview in early December. The first one is distillation with stored completions. And if you missed it, Masa did a great demo actually yesterday, and I'm sure it'll be available online. One of the biggest challenges in fine-tuning is getting the data set that you need, having all of that labeled data of your customer traffic. And that is now easier than ever with stored completions and evaluation, where you can actually select data on a session level, choose to store it within your system, and then split that data for evaluation and fine-tuning purposes. We also have vision fine-tuning that we're going to demonstrate for you here in a moment, which takes one of my favorite use cases of these models, which is multimodal vision understanding. That is the ability to read a chart or understand a picture of the world and gain context from that. and make it better through fine-tuning. We have amazing partner integrations, and we're going to be highlighting the weights and biases integration today, which is a tool that many data scientists are already using as part of their training processes to evaluate and build great models for specific use cases. And the weights and biases team are going to show you how that integration works. And finally, one of the other challenges that we've had on our platform with fine-tuning is how do you scale? Once you've built this model, can you deploy it? Now we're the only platform today that provides provisioned throughput with a fine-tuned model. That is, you can take a fine-tuned model and deploy it to our highest scale offering that's on Azure OpenAI, as well as being able to deploy it anywhere in the world with our global standard deployments. So with that, let me actually invite Ами up here on stage, who's going to show us more about vision fine-tuning. Ами, why don't you give her a round of applause as she's coming on stage?
Thank you. Thanks, Steve. I'm just going to quickly log.
So as you're getting this set up, Ami, tell us about the scenario that you're thinking of fine-tuning today.
OK, so oftentimes in our business as well, like we're always looking at these very complex data visualizations. Like you'll see all these crazy lines, these colors, these gradients, and you're just like, hey, I kind of just want to know like what the trend is and this percentage. And it takes a while. We're here trying to operate really fast in this era of AI. So we're going to see if I can fine-tune GPT-4o to make this even easier and get some crisp, quick responses.
Awesome. Let's see. I'm looking forward to it.
OK, so I'm going to go ahead and get started. Let's make sure you all can see my screen.
Now, are you inside the new Azure AI Foundry, Ami?
Yes, I'm inside Azure AI Foundry with this new revamped navigation as well as landing page for Azure OpenAI Service. You can see all the tools that you know, you love, that you've used in Azure OpenAI Service in Azure AI Foundry. So here you have your playgrounds. You have that we will go into, fine-tuning, of course. We have, just as you mentioned, the Azure OpenAI evaluations. We have the soon-to-come-to-you, the stored completions for distillation, as well as batch jobs and all your shared resources.
Fantastic.
Yeah. So just to get right into it, before we play and fine-tune the model, let's just see how well GPT-4o does for us. So we have that comparison in realm when we do fine-tune the model, because we want to make sure we're making some improvements before we really see what we're working with. As you mentioned, we want to get started with some prompt engineering, see how the charts play out.
Yeah, that's right. I mean, this is effectively the third technique in customization, right? You start with prompt engineering, then you go to RAG, and if that's not getting you there, you could fine-tune. But let's see how effectively you're doing a manual retrieval here by copying and pasting data in. Let's see what it does.
Yeah, so I've already just copied my image in, and I'm just going to ask, what is the pay gap between men and women? And let's just see how GPT-4o responds.
OK. So you passed in an image with a prompt. What is the pay gap between men and women with GPT-4o in this complex chart? And what did it say?
It says the chart illustrates the pay gap. It's measured as a percentage, a lot of information. Then it gives me the levels and information. So it is pretty accurate, but there's a lot to parse through. And I'm sure, Steve, you don't have enough time to read through that.
I really don't. I would love a much more succinct summary. And I also know you've been testing this a few times. And the accuracy is what, maybe 50% when you use that prompt?
Yeah, sometimes it'll say the right thing, and then the next day it does, and the next hour it does. And we don't like inconsistencies here. No. When you have to report up to your chain, if those numbers are wrong, I don't know, they might come back to me and ask me more questions.
Absolutely. I mean, this is statistical information. It needs to be accurate.
Yeah. So let's now look at a little bit of another chart that may be more realistic to what we use at work, which is a stacked bar chart with all these gradients. And let's start simple. Let's say let's start with how many colors are in this chart, just to keep it simple and straightforward.
OK. Thinking about it.
OK. It got it right. OK. Now let's ask it maybe what is the average % of very low degree burnout? Let's see how that goes.
So again, the 4o models as a base level are actually pretty good. They can do some things all right. But maybe we want to change the style, or maybe we just need more specific information.
Yep, exactly. So let's just see. Maybe this gets it right. It should be around 20-ish %. OK, it got 20%.
OK, so it's pretty good. Now, what if, Ami, though, I want to challenge you? right? Like, I really need this to be able to deliver to my executives, and I want accuracy closer to 100% of the time. I actually want a more succinct response.
Yep.
Can you do that for me, and how would you do it?
Yep, I definitely could do that. So the first step to fine-tune this model is data. Like, before all else, like, even if you have the greatest desire to fine-tune a model, you need training data. So what I've done is, I did a little searching on the internet, and I found this data source that I'll actually show here with 3,000 images in the same format that you know and you're familiar with if you have fine-tuned with us before. Just to go a little closer, because there were a lot of lines there, this is what the actual message JSON looks like. So you'll see here I have the same system message, the user message, and even the same content, like the assistant response. But what's new with vision fine-tuning is that I have this image URL. So this can either be a image URL, or it can be like the raw input that you have already, and then you can just add that content in to fine-tune for vision.
Okay, so this data set is literally a data set you found on the internet with a bunch of charts,
Yep.
put into a JSON format pointing to the files, and so you're going to train it on a whole bunch of different charts. This is not specific charts from our organization yet,
Yep.
but even doing this training will make it better at reading charts generally as a task.
Correct.
Okay.
So now let's go ahead and jump right back. So what I'm going to do now is, within this new, Azure OpenAI Service within Azure AI Foundry, I'll go to fine-tuning in Tools. And then here I can go ahead and, one thing actually you'll see that's new, that Steve already pointed out and we're going to see more of, is we have this manage integrations. And you'll see in a bit how you can enable this with weights and biases. So
Awesome.
stay tuned.
Look forward to that.
And now I'll go ahead and click Fine-Tune Model. I can see all of the fine-tune models available for me with Azure OpenAI Service.
Okay, and I believe today, and you can correct me if I'm wrong, 4.0 Mini happens to be the model that people most often fine-tune today on our platform. Is that right?
Correct.
Yeah, because you can use the same power of a 4.0 model, but get 4.0 Mini to behave for your task with the same quality, if not better.
Correct.
And that becomes a huge cost savings too, right?
Yes, 100%.
Awesome.
We're seeing that grow really exponentially, and a lot of our customers are loving to try it out.
So,
But today, we'll be using 4.0 because we want to fine-tune those charts.
okay, so we want the most powerful example here.
Yes.
So we're going to choose 4.0. Got it.
Yes. And so now I just selected 4.0, and then you'll see me start to going through the wizard. And again, you see this great new addition where you can log the job to find weights and biases, and we will see that in a bit. So just stay tuned. And so now I'll use a model suffix, which is vision demo, just so I can clearly identify this fine-tuned model. Now I just have to add the training data, and I already have the training data, and I can just click next. As you can see here, I'm just going through the steps in this flow, and there's not really anything hard about this part here. I'm just adding the inputs as I do it. The hardest part was already done, which was getting that training data here. And even for me to upload that training data, you might have noticed I never need to even imply or indicate, hey, I want to fine-tune for vision. The API already detects that you have image in your data based on the JSON you saw earlier, and then it knows that you want to fine-tune for vision.
Now, if I can jump in here just for a moment, because this is a question I get a lot, which is, okay, if I'm adding my data to the service, is it still my data?
Of course, 100%. We don't use that data for ourselves. That data is yours and yours only. You'll see that data in your data files in Azure OpenAI Service. You can delete it, you can remove it, but it only belongs to you.
Fantastic. I love hearing that.
So just going through really quick, as I said, I'm adding some validation data. Now here, I can keep the defaults, keep the random seed. I can play with it if I want. I can just use these sliders. And I'm just feeling like I can just, put in a number here and go with the defaults. And just review and submit.
Okay, so now in the background, it's going and training this model using the data that you provided,
Yep.
correct? Fantastic.
Yep, you'll see here it's queued. Now, as I said, there's 3,000 images. It's about 8 million tokens. You'll see if I click into one that I've already done, it took about 7.5 hours. We're not going to wait for the one I just submitted, which is why I did this ahead of time for you all today.
Well, that's good. I'm pretty sure people would start getting hungry.
Maybe I'm hungry 2 or 3 times. Yeah.
Okay.
So instead of that, we are going to quickly jump forward to the training is now completed, and now I want to understand, hey, does this work? Is this good? What's going on here? So what I'll do is I'll go to the metrics tab.
Okay.
And here I want to look at the loss and accuracy curves. I want to make sure my loss curve is trending downwards. So I get that really nice downwards curve. And then for accuracy, we get that really nice upwards curve.
Fantastic. So using this training data set that you provided, it's actually logging those metrics and is saying on that data, the accuracy is actually proving through these training runs.
Correct.
Fantastic.
And one thing people also look at, because I did add validation data, you will sometimes start to see like, your validation data maybe go up and, curve with your loss and like overfit a little bit. But even if that happens, what's really cool that we have here is you'll see these like red plot points, and these are checkpoints. So like, let's say I'm like, oh, I don't really like how this step to 1200 is like overfitting a little too much. I can go to checkpoints, and I can actually deploy an earlier checkpoint of my training, so then I don't have to worry about retraining again, spending more money. I can just deploy the model at an earlier training time.
That's fantastic. That's great to see.
Yeah. And so it looks good. I'm pretty happy with this. I'll go ahead and deploy it. But let's say I had data that was not really safe and may have tried to skew the model in a direction we don't like. Responsible AI and trustworthy AI is a big part of our organization. We make sure we're being secure, trustworthy, we have safe. What happens? So I actually have an example right here of like what happens when I unknowingly or even knowingly or someone has tried to do that.
So I just downloaded data off the internet. What if a malicious user went and put some bad data in the middle of that data set? You're telling me you've got some controls in place for that?
100%.
Fantastic.
And sometimes you're like, oh, there's a data set, like you're not gonna go through 300 lines of data. Like it's a bit difficult. So I can see here that the job has actually failed. I see a message that says the user data has failed data safety check. This means that our responsible AI service actually caught that there was some training data, one of the images or something that was not safe. So if I go to logs, I can see here training file, pre-processing summary, the provided data failed RAI checks for harm types, violence, self-harm, sexual, hate, fairness. Please fix the data and try again. So this message just gives me a clear write-up of these are the lines where you may have malicious or harmful data, just for me to go in and check and validate. We also have other safety measures, such as let's say there was maybe a row in your data set that had an invalid format, or it was just one data row. We also do skipped data rows. So we don't fail your job, but we will let you know hey, these rows were skipped.
Okay. Now, what if I happen to be working in a sensitive domain, maybe healthcare,
okay,
where by default the safety checks might block my data, but I check and it's valid? Can I find a way to exclude those checks?
Yeah. So what you can do is you can make sure when you do deploy, when you fine tune the model, you just make sure hey, you give it a really good system prompt. And don't try to jailbreak it because that won't work. But and then put the data in, and it should hopefully fine tune. And if not, you can just reach out to one of us, and we'll help work with you to.
Through our support teams, you can request
you can work with us.
To be turned off, but it is on by default. So I've got safety by default that helps me sleep at night. Exactly. And if I really need to, I can apply and have it turned off.
Exactly.
Okay.
So now let's go back to our actual successful run that we did not have harmful data, and go. This was our running one, our completed one, and let's go ahead and deploy it.
Awesome. Now, is this deployment going to take days? Is it going to take
It'll
weeks?
take a couple of minutes, so okay. I'm just going to walk us through it. But I already have one deployed just because it is larger, and I want us to quickly get into playing with it and having that fun. I also realized I didn't have quota because I deployed the other fine-tuned model earlier, and I made sure I had enough tokens. So I typically would not hit this error, but because I wanted to make sure I had the best rate limits, the best just for this demo today, that's probably why I hit this error.
You used all your tokens.
I really did use all my quota, yeah.
Okay, no problems.
So,
and you could always apply for more quota if you needed to.
Yeah, I can easily hit that link that you saw earlier in the error message that said request more quota and get more quota if I wanted to have many deployments of my fine-tuned model.
Okay, so once it's deployed, you can just find it right there. That's
yep.
fantastic.
I just have to click switch, and you'll see here I have this new chat session started. The assistant setup has been updated, and the previous messages won't be used. So I don't have to worry about hey, it's relying on my base model. This is a new session. No worries there. And I'll just actually go into the same questions I had. Just copy the image over.
Now, if I remember, I wanted a more succinct response, right? Something that is going to be easier for me to read. Let's be honest, I get a lot of emails every day, so I'm looking for nice, accurate, succinct responses. Let's see how this model does.
It's a little better. Like this one, like there is like a sentence, but it's not as lengthy as the first response, as you can see here.
So it definitely changed the output format.
Correct. And it's still accurate. Let's try with the other image, because that one was definitely something that could be way more succinct. And curious to see, like, we can just ask it the same question. Let's see if it just says 5.
All right.
5.
Boom, single answer. Hey, that's pretty cool.
Okay, and then let's look at the average % of burnout. 22, just straight to the, and it's more accurate. If you remember earlier, it was 20.
20-ish%. Now it's 22. It's
right.
statistically accurate.
Yeah.
I can send that to my manager, and I'm not going to get fired.
Yeah, and then you won't fire me, hopefully.
That's fantastic, Ami. Thank you so much for showing us that. That's an amazing demonstration of vision fine-tuning.
Yeah.
All right, let's give Ami a round of applause. Now I'm going to have Anish come and join me on stage, because one of the things that you saw within the demos as well is that we now have weights and biases integration, which helps us get even more control, more insight, and more understanding about what's going on with fine-tuning. So, Anish.
Hello, everyone. So today we're going to talk about a use case really near and dear to my heart, which is about the understanding of doctor-patient dialogue. So at least I have family in the healthcare industry who tells me, or I can say complains quite a lot, about how a lot of their time is actually writing patient's notes after the fact to actually sit down and have some actionable items to continue with after speaking to a patient. And so I think that there's a lot of interesting capabilities for us to use large language models to help aid these healthcare professionals in reducing the amount of work needed to actually get to that style, form, and format they need to glean from this unstructured form of conversation. Something that's not only also localized to healthcare, but to most industries. But we'll talk about it in the healthcare perspective first.
Joanna, I love that scenario. I was actually at the doctor a few weeks ago just having an annual checkup, and it struck me how much time the doctor was spending writing information on their computer versus helping care for me. And I thought, man, that's a real burden. Like, we want accurate notes, though. Like, how can I trust a model to automatically record that information?
Yeah, and so that's why one thing that's really important, and I love about this partnership that we have, is that all of this breaks down to proper experimentation routine. So you're going to be fine-tuning a lot of different models on the Azure AI Foundry, and you're going to be looking at a lot of interesting charts and outputs, either via chat or programmatically, to get to the point where you can say, this is sufficient, so I can now test it with real users, maybe bring it to a specific small batch of hospitals, for instance. And so what you see up here right now is a lot of unstructured text that is extremely hard to read. Yes. But this right here is also what you work with initially to get to the point, which Ami mentioned earlier, about getting to good data. So let's pretend I took some time and really put it in a form that's a lot more human readable. So this is where we're going to start looking at the interplay between Azure AI Foundry and the experimental nature of the weights and biases platform. So what you'll see as I hover through this is the actual conversation itself, and then the final annotated note that we care about. So this is when we actually sat down and had a doctor sit down and write down what they believe is the next proper action items. So this is what we're going to be using to actually fine-tune our model. And you can do some data processing behind the scenes to make it that nice conversation form or the OpenAI spec that the Azure AI Foundry models really anticipate and has also been the standard that we're all used to as developers or end users. So now if I were to jump in and actually fine-tune the model, it's as straightforward as Ami showed us earlier. So we can quickly go into here, click Fine-Tune Model. In this case, I'm going to use the 3.5 Turbo model just to keep things nice and quick. And we're just going to do the same steps that we saw earlier, except, back in the basic. We are going to log this fine-tuning job to weights and biases. Oh, no. Sorry for a second. I'm going to quickly.
So while you're pulling that up, I just wanted to play back. One of the tasks I said that's hardest at the beginning is getting the data. And so you saw one example from Ami where she just downloaded a public data set. But in the case of healthcare, I want very specific data because I want it to be applicable for my organization and what I'm doing. So you had doctors come and annotate. In other words, doctors read patient notes. They wrote what they would have said in their notes. That's your labeled data. You put it into the JSON structural schema, which these models need, and now you're going to fine-tune with it.
Exactly. And so as I was showing earlier, and also Ami showed, is that it's as simple as uploading those JSON files into your private Azure instance, so no leakage anywhere, and then just pressing a couple next buttons until you get to the point where you may want to decide some hyperparameters. In this case, I'm going to choose the defaults, though I'm going to choose my favorite seed, 42, in this situation. And then we're going to press submit. And so what's
I
really
did hear at least one sci-fi fan laughing out there on 42.
Thank you.
Good for you.
And because behind the scenes, we were able to set up the integration properly under that Manage Integrations tab, where we set up the proper key vault and secret, all of which magically sets up the connection to communicate with weights and biases. What we also get from this is that once we have a completed job, so right now this one's a queued one, and we're going to just let that run in the background. We're going to go to one that's already been finished. And so jumping into this, we can already see that there's already a nice URL here that will already automatically take us to that project I defined earlier. So when I click this project dashboard, you'll see it'll actually open up one individual experiment, quite similar to the charts that we saw earlier that Ami showed, which show us the accuracy over time for both training and validation. So you can see kind of spikes here and there, and also the accuracy over time. But the beauty of centralizing all of these experiments into one location is that we're able to actually make much more systematic decisions about which model to use.
Oh, wow. So I could actually compare my different training runs with one another. Is that where you're going? And different models?
Yeah, exactly, Steve. So you can see here that as I start to scale, not from just these 6 experiments you see on the side, when I go to hundreds, if not thousands of experiments I'm running at scale for different versions and batches of data, all of which can be tracked and versioned in our platform, you can go here and use the collection of tools data scientists are familiar with, and you are all now data savvy folks, and understand which model to best use. So in this case, it's a bit hard to see which has that nice slope that Ami mentioned earlier. So I'm going to use some standard tools to get to that point. So I'm going to smoothen some of these lines, maybe turn off a couple of these charts because they're all a bit too much, and turn on maybe a few that I just want to investigate. Let's say these 3. So if I were to actually go and zoom in, for instance, I'll be able to see much more better patterns to understand which model is actually the best. In this case, I really like this blue line here. I see it kind of has the slope that I'm expecting as a data scientist, and you can just take my word for it. And I also see that the accuracy has a nice curvature that represents it increasing and getting to that maximal accuracy that can get to.
So this is really going to accelerate my experimentation time, because without this, I'm effectively taking a model, training it, deploying it, having users test it, getting the feedback, and going through that process again. Now I can use these statistical tools to actually gain faster insights with small adjustments as I'm going through the process.
Exactly. You're exactly seeing the point right there. And what's next is that once you get to that point where you find those experiments you really like, if you don't share these results, you lose them. That's the nature of the information world we live in. So if I were to go and click in this reports tab here, I'm able to actually take all this information and write it in like a OneNote style, where I can go in and write notes about what I just did experimentally, maybe explain the solution architecture and the idea, even some code snippets if I want to, and actually have a live dashboard that updates with each new experiment with the settings I care about. So that's smoothing pre-applied, for instance. So I can go in and say to my colleague, Steve, for instance, I can say, hey, Steve, 𝗬𝗲𝗍 Steve, the blue model is definitely the one to deploy.
So this is fantastic just for documenting your journey. I imagine I could also use this as part of my regulatory documentation if I needed to be able to show my auditors or my second-line functions, hey, what information did you use? Why did you choose that specific model?
Exactly. The full audit trail is there. So we saw that data set where it lived. We know all the experiments and the key decisions we made alongside reports to explain our process. And so the natural next step is to go back to our Azure AI Foundry instance and deploy that blue model. So similar to what Ami showed earlier, we can go into either the deployment section under shared resources to do it, or go back to the fine-tuning jobs and click it. But I'll just show it from this tab, where you can go here and just click Deploy Fine-Tune Model and have a really easy list to choose. And that links really easily back to the weights and biases instance. If you're ever confused, you can actually choose the one experiment. I apologize. So let's say this is the experiment that I thought was best. There's also an easy way in the workspace itself to link right back to that same fine-tuning job we cared about. So there's that dual linkage that's really important from both sides. But we have this now model deployed. We may have someone like an AI engineer jump in and use the tools they're familiar with, such as the Azure OpenAI endpoint, with some proper authentication, link to that specific model we just deployed, and just easily swap that in with their current stack that's already in production. So from a programmatic perspective, AI engineers in your team can hot swap between their newest fine-tuned model with minimal change in code.
That's fantastic. So if I'm continuously training this model, is where you're going with this,
yes.
I could be updating this every month with new data, new labeled informations, and I don't have to switch my application over to a brand new endpoint, migrate all my users every time. I can just inline update that
Exactly.
model. Fantastic.
And just like one final piece is, we need to prove that this fine-tuned model is actually better than the original one. So once you also work within the weights and biases ecosystem, you have access to a lot of other statistical tooling. So like in this situation, I may want to qualitatively analyze the decomposed thought process of our model, for instance. So like in this case, I may want to actually understand, in the context of my application, what inputs are going into this model, so like in this case, that actual doctor's note, and see how something like our GPT model responded. And if I were to show you the true output of the note itself, this output, while looking fine, is not in the form or has the degree of detail that we care about. For that same example, I can go back and actually see how the fine-tuned model actually outputted this. So in this situation, you can see that there's much more granular detail about what the actual action items are for the doctor given that unstructured data.
This looks just like a real patient note that would go back to a patient or to a medical provider if they needed to be able to take action on that.
Exactly. And then if we want to actually apply a little bit understanding about the quality too, we can actually start to do things such as score those models using a variety of tools, and then visualize it in a form where you can say, this model is doing the best for sure. So like in this case, the red model is the fine-tuned model, while the blue one is the unfine-tuned one, so the base GPT 3.5 turbo model. And you can see that from the fine-tuned model, if we were to return back to the base model, we lose about 35% accuracy. And that is something that's
huge.
Yeah, exactly. And so that's why fine-tuning is such a powerful paradigm, and having the tools to validate that are extremely useful. And so I'm excited to see what we're going to build next with the Azure AI Foundry team, and build the right tools so all of you can go back and use AI effectively in your products.
That's fantastic. Thank you so much, Anish. That's amazing to see. Good job. All right, so thank you so much for showing that. And it's amazing to see the basics of what you can do within the Azure AI Foundry with fine-tuning, and the extensibility that we have with the amazing partnerships with customers like Weights and Biases. And so I want to just thank the Weights and Biases team for doing this amazing integration, and we look forward to more partnerships coming up as well. And as you can see, fine-tuning and customization is an important step in ensuring that these models can meet your domain-specific and application-specific tasks. Hopefully today out of the session, you got some confidence that while fine-tuning is challenging, it's actually worth the investigation. And it's worth actually using to be able to improve your applications and meet your business needs in more powerful ways. And like we said, if you want to know more about distillation, we had an amazing demonstration yesterday, which will be available online. And you can see how you can use stored completions to capture some of your data as well. And we've got these other amazing sessions coming up where we'll go into more details on fine-tuning, as well as some of the other applications across domains like healthcare and other services. So thank you all for coming. We are out of time, so if you have questions, I'd say please feel free to come up after the session. And thank you very much, everyone. I appreciate it.